this object was first seen, it wasn't really clear this is an interstellar object. This object is much larger and much brighter, and we have a lot of time to observe it.
It's coming in fast from outside the solar system. What if it's not a comet at all? Something just entered our solar system from interstellar space. Glowing early, moving fast, and breaking all the rules. Not because it's dangerous, but because it's different. An outsider is here, and it's flying straight through our solar system. Welcome to the mystery of 3I-ATLAS. A visitor from the dark. A body is racing toward us from interstellar space. It isn't like the comets we know, and it isn't an asteroid we can chart. It's something far stranger. Its official name? Comet 3I-ATLAS. Doesn't sound dramatic, but this object is anything but ordinary. It's only the third interstellar object ever discovered passing through our solar system. Before this, we had Oumuamua in 2017, the long cigar-shaped oddity that slipped away before we could figure out what it was. Then Comet Borisov in 2019, which behaved more or less like a normal comet. Now, here comes 3I-ATLAS, and it's already raising eyebrows. The comet was first spotted in July 2025 by the ATLAS telescope system in Chile. At first, astronomers thought it was just another comet drifting along its orbit. But then the calculations started to come in. Its speed? About 130,000 miles per hour. Way too fast for anything native to the solar system. For comparison, Earth orbits the Sun at just 67,000 miles per hour. That speed matters. When astronomers trace its orbital path, they see a hyperbolic trajectory, an open curve, not a closed loop around the Sun. In simple terms, this thing isn't from here. It came from deep space, and once it swings past the Sun, it's gone for good. A true interstellar visitor. Of course, that raises the question, what exactly are we looking at? The best images we've got so far come from the Hubble Space Telescope, which snapped a view in July 2025 when the comet was about 277 million miles away. What Hubble saw was a faint teardrop-shaped cloud of dust surrounding a tiny solid core. That fuzzy glow, called a coma, makes it look like a standard comet. But the nucleus itself, the solid heart of the object, is tiny, somewhere between 1,400 feet and 3.5 miles across. A speck by cosmic standards, yet massive enough to punch through our solar system at breakneck speed. Astronomers around the world are already watching it closely. NASA and ESA have lined up almost every major telescope and spacecraft to track its journey. Now, is it dangerous? No. At its closest, 3I-ATLAS will stay about 167 million miles from Earth. That's nearly twice the distance to the Sun. But safe doesn't mean boring. Because with objects like this, every anomaly, every flicker, every twist in its path leads to the same question. Is this just a comet or something else entirely? For now, it's a mystery. A mystery flying straight at our solar system. And the story is only just beginning. What is it and why it's different? So what exactly is Comet 3I-ATLAS, and why are astronomers calling it unusual? Let's start with the basics. At its core, 3I-ATLAS is small, really small. Observations from the Hubble Space Telescope put the nucleus at somewhere between 1,400 feet and 3.5 miles across. Picture a city-sized ice ball wrapped in a halo of dust. That glowing shroud, called a coma, is what makes comets visible from Earth, and 3I-ATLAS already has one. But here's where things get strange. Usually, comets develop their coma when they heat up as they approach the sun, with ices boiling off into space. That typically happens once they cross the orbit of Mars. But 3I-ATLAS started glowing far earlier, while it was still way out between Jupiter and Saturn, an area so cold most comets stay frozen solid. Early interpretations suggest its coma is loaded with carbon dioxide gas, far more than the water vapor we normally see. Some estimates suggest 20 times more CO2 than H2O. That's rare. Not unheard of, but rare enough that scientists are paying attention. Why would an interstellar comet be made of something so different? What conditions shaped it before it ever entered our solar system? Even stranger are the flickers in its brightness. Comets usually vary in brightness in steady, mechanical ways. They spin, tumble, or break apart, but it's predictable. 3I-ATLAS doesn't behave that way. Its changes in glow are irregular, almost like pulses. Not exact like clockwork, more like rhythms. Some astronomers have compared them to biological cycles: sleep, wake, repeat. Now, to be clear, the official line is that this is natural. Maybe jets of gas are venting at random. Maybe the comet's surface is fractured in unusual ways. But the irregularity stands out, especially compared to Borisov, the last interstellar comet, which behaved almost perfectly like a normal solar system comet. Add all that together: early coma, unusual chemistry, irregular pulsations, and you have something that doesn't fit the mold. Is it just a comet? Almost certainly. But almost is the key word. Because once before, we had an interstellar visitor that broke the rules. Oumuamua. Thin, elongated, and accelerating in strange ways, it left us with more questions than answers. Some scientists speculated it could even have been an abandoned probe or a fragment of alien technology. That debate is still unsettled. And now, with 3I-ATLAS, we're watching another outsider. And once again, the universe isn't giving us easy answers. This isn't just another comet, it's a puzzle that's drifting closer every day. Speed and origin. One of the clearest signs that 3I-ATLAS doesn't belong here is its speed. Objects born in the solar system move in familiar ranges. Earth circles the sun at about 67,000 miles per hour. The asteroid that wiped out the dinosaurs hit at just 33,000 miles per hour. Even the fastest comets we track rarely go beyond that. 3I-ATLAS is different. It's moving at roughly 130,000 to 193,000 miles per hour, almost triple Earth's orbital velocity. At that speed, it's like a bullet cutting through traffic. And speed isn't just a number, it tells us something fundamental. This object isn't bound to the sun. Astronomers calculated its orbit and found it doesn't follow a neat ellipse like a planet or a comet that belongs here. Instead, its path is hyperbolic, an open curve. That means it came from beyond our solar system and is just passing through. Once it swings by the sun in October 2025, it will never return. That's why it's been labeled 3I. The I stands for interstellar. The 3 marks it as only the third interstellar object ever detected. Out of all the rocks, comets, and asteroids humanity has cataloged, only 2 others, Oumuamua and Borisov, came from outside. Now, 3I-ATLAS joins that very short list. Its direction of travel is also unusual. While nearly everything in the solar system orbits counterclockwise around the sun, 3I-ATLAS is cutting in on a retrograde path, clockwise. It's coming in at a shallow angle, about 5 degrees off the plane of the planets, almost as if it's slicing across the solar system sideways. That trajectory means it won't stick around long. It will skim past Mars's orbit and dive toward its closest point to the sun, about 130 million miles, just inside Mars's track, before slingshotting back out into the galaxy. By December 2025, it'll already be pulling away from Earth's orbit, heading back into the void. And that raises the question, where did it come from? Tracing its path backward, astronomers can't connect it to any known star system. It seems to have drifted for millions, maybe billions of years, before wandering close enough to be pulled toward our sun. While scientists see random drift, others point out how precise its course looks. Retrograde, shallow angle, on a path that threads right past Mars, close enough for multiple spacecraft to watch. Is that just luck? Or is it something else? For now, the safe answer is chance, but it's hard to shake the feeling that this visitor didn't just stumble into our neighborhood. Path through the solar system. So where exactly is this visitor going? The answer, right through the heart of the solar system, but not too close. 3I-ATLAS is on a trajectory that takes it in from deep space, past the outer planets, and toward the orbit of Mars. On October 30th, 2025, it will reach its closest point to the Sun, about 130 million miles away, just inside Mars's orbit. For context, that's a little farther out than Earth's closest approach to the Sun, and well beyond Mercury's scorched track. Along the way, it will pass remarkably close to Mars. Astronomers calculate that on its inbound leg, 3I-ATLAS will skim just 18 million miles from the red planet, practically a hair's breadth in cosmic terms. That close brush makes Mars the perfect outpost for observation. NASA and the European Space Agency already have a fleet of satellites and rovers stationed there, and their instruments will be trained on the Comet during its flyby. For Earth, though, the approach is more distant. At its closest in December 2025, 3I-ATLAS will pass us at about 167 million miles away. That's nearly twice the distance between Earth and the Sun. Far enough that it poses no threat, but close enough to stay on astronomers' radar. Its orbit cuts across the solar system in a way that's unlike most comets. The planets all orbit counterclockwise. 3I-ATLAS is cutting in clockwise, moving almost against traffic, and it's doing it at an angle, dipping into the plane of the planets from above, like a cosmic outsider ignoring the rules of the road. Even more curious, for much of its journey, Earth will be hidden on the far side of the Sun from the comet. That means direct observation from the ground will be limited at times, almost as if this object is deliberately staying out of sight, though of course that's coincidence. Still, the geometry is unusual. The comet seems to be threading its way between the orbits of Mars and Jupiter, skimming the inner solar system before escaping back into the dark. Astronomers will only have a short window to gather data before it disappears forever. And that's why nearly every major observatory is focused on it. Ground-based telescopes, space-based observatories like Hubble and Webb, and orbiters around Mars will all contribute. It's a coordinated observation campaign unlike anything seen for previous comets. Because once it's gone, it's gone. 3I-ATLAS won't return in our lifetimes. It won't return at all. That's what makes its path so fascinating. Not just where it's going, but the questions it leaves behind as it streaks through our corner of the galaxy. Observations from across the fleet. When something unusual enters our solar system, the scientific world doesn't waste time. And in the case of 3I-ATLAS, the response has been extraordinary, and it's already being tracked obsessively. NASA and ESA have lined up almost every major telescope and spacecraft to watch this thing. Hubble, Webb, even satellites around Mars. The message is clear. Scientists don't want to miss this opportunity. The first big clue came with the Webb Space Telescope. Normally, Webb's schedule is locked down months in advance. Its fuel supply is precious, and every adjustment is carefully rationed. But when astronomers realized 3I-ATLAS was interstellar, Webb's priorities shifted. Out of schedule, the telescope was reoriented to capture data. That kind of flexibility is rare, and it signals just how important this object is to the astronomical community. And Webb isn't alone. Nearly every major space observatory is now watching. Hubble has already taken deep exposures, showing a faint, teardrop-shaped coma streaming from the nucleus. TESS and SWIFT are slated to collect light data. The SphereX infrared surveyor, still preparing for its main mission, will try to sniff out chemical signatures. Even probes designed for other tasks, like Parker Solar Probe, Lucy, Psyche, and Europa Clipper, have been tapped to gather whatever observations they can. But the most unique perspective will come from Mars. 3. I-ATLAS's close pass by the red planet means a fleet of orbiters and rovers are perfectly positioned to capture data. ESA's Mars Express and Trace Gas Orbiter are already adjusting their cameras. NASA's Mars Reconnaissance Orbiter will attempt long-range imaging, while the Perseverance and Curiosity rovers will provide supporting sky observations from the surface. Never before has an interstellar object passed so close to an active robotic science base on another planet. The strategy is clear. Throw everything we have at it. From Earth, from orbit, from Mars, even from deep space probes. No one wants to repeat what happened with Oumuamua in 2017 when the strange visitor was spotted too late for meaningful study. This time, scientists are ready. And why so much interest? Because interstellar visitors carry information no local comet can. Their chemistry tells us what other planetary systems are made of. Their surfaces reveal what conditions are like far from our sun. And their trajectories give us clues about how objects travel between stars. But with 3I-ATLAS, the intensity of the observation campaign also hints at something else: curiosity about its anomalies. The early coma, the unusual chemistry, the irregular brightness. If there's even a chance this object holds answers, or surprises, scientists want the data. 3I-ATLAS is under the spotlight. Humanity's entire observational arsenal is trained on a single cosmic visitor, because once it slips behind the sun and then out into the void, all we'll have are the records we make now. Unusual comet behavior. On the surface, 3I-ATLAS looks like a typical comet, a small icy body with a glowing cloud of dust around it. But the closer scientists look, the stranger it seems. Most comets begin to form a coma once they cross inside Mars's orbit, as sunlight heats their icy surfaces and vapor jets into space. 3I-ATLAS, however, lit up far earlier. It started glowing well beyond the orbit of Jupiter, in regions so cold that most comets remain frozen solid. That's the first red flag. Something about this object is reacting in ways that don't match expectations. The second anomaly is its chemistry. Normally, comet comas are dominated by water vapor with smaller traces of other gases. But 3I-ATLAS is different. Early readings show its coma is unusually rich in carbon dioxide gas, far more than astronomers are used to seeing. Perhaps 20 times more CO2 than water. While CO2 isn't unheard of in comets, this extreme ratio is rare. Why would an interstellar comet carry such a different chemical fingerprint? Did it form in a colder, drier system than ours? Or is something else going on? The light curve, or the way its brightness fluctuates over time, reveals another mystery. Normal comets brighten and dim in predictable cycles as they rotate or shed dust in repeating patterns. 3I-ATLAS refuses to follow that rhythm. Its brightness fluctuates irregularly, like pulses that don't match the mechanical precision of physics. Some astronomers describe these flickers as looking less like a clock and more like a biological rhythm. irregular but consistent in their own way. That comparison has fueled speculation far beyond the scientific mainstream. Could it be venting gases in bursts like breath? Could its spin be unstable, causing unpredictable flashes? Or, as some enthusiasts whisper, could it be artificial, built to behave this way? To be clear, most scientists caution against jumping to conclusions. They suggest that fractured surfaces, uneven gas vents, or hidden layers of volatile material could explain the irregularities. The object may simply be falling apart in ways we don't fully understand yet, but the fact remains. Its behavior is unusual enough to command attention, and in science, anomalies are gold. Every irregular flicker, every strange chemical reading, every unexpected tale is a clue. A piece of evidence pointing toward the origins of this visitor. Whether natural or not, 3I-ATLAS isn't acting like a typical comet. And that mystery, that sense of something different, is exactly why astronomers around the world are pushing their instruments to capture every possible detail before it vanishes into the dark again. Manufactured or natural? Whenever something strange arrives from deep space, the question inevitably follows: could it be artificial? Oumuamua sparked this debate in 2017. Its thin, elongated shape and unexplained acceleration led some researchers, including Harvard astronomer Avi Loeb, to suggest it might be an alien probe or debris from an advanced civilization. Most scientists disagreed, pointing to natural explanations, but the idea stuck. Now, with 3I-ATLAS, the same whispers are starting again. The transcript of its behavior is full of oddities: early coma, CO2 heavy chemistry, irregular pulsations in brightness. On top of that, some amateur observers claim its core is unusually rich in nickel without the usual balance of iron. Normally, nickel and iron are forged together in stars and supernovae, showing up in space rocks at about a 1:4 ratio. Finding nickel without iron would be extremely unlikely without some sort of separation process. In other words, technology. So, is 3I-ATLAS a comet? Or a craft? The evidence doesn't go that far. Official observations from NASA and ESA show the nucleus is still very small, between 1,400 feet and 3.5 miles across. There's no sign of engines, signals, or manufactured surfaces. Its coma and tail look like dust and gas, not exhaust. Most astronomers see nothing more than natural, if unusual, cometary behavior. Still, the trajectory raises eyebrows. The comet is cutting into the solar system on a retrograde orbit, moving clockwise against the planets. It will skim close to Mars and swing just inside its orbit of the Sun before heading back out. To some, that path looks too perfect, almost like a deliberate tour, especially since Earth will spend much of that time hidden on the far side of the Sun, as if the object is avoiding direct detection. Coincidence? Almost certainly. But coincidences on a cosmic scale have a way of feeding speculation. And speculation matters. It fuels interest, brings more eyes to the data, and sometimes pushes science to consider possibilities it might otherwise ignore. Scientists are careful. They look for mechanical explanations first. Uneven vents, unstable spin, fractured surfaces. These are the working theories. But outside the lab, the conversation is more open-ended. If it is just a comet, it's still extraordinary. Only the third interstellar object ever recorded, and already one of the strangest. If it isn't, then it would be something far more profound. For now, the safe answer is natural. But the mystery lingers, and with every irregular flicker and every odd reading, the question remains alive. What if it isn't? Stakes and imagination. When something unfamiliar enters the solar system, people can't help but ask, what if? With 3I-ATLAS, the speculation runs wild. If it were to change course and head for Earth, the panic would be instant. Headlines would scream about alien craft. Social media would ignite with conspiracy theories. Governments would scramble. In a world already tense with conflict, the arrival of a possible spaceship could trigger hysteria overnight. Of course, the scientists are clear. That isn't going to happen. At its closest, 3I-ATLAS will still be 167 million miles from Earth, nearly twice our distance from the Sun. That's nowhere near a collision path. Astronomers emphasize that it poses no threat to Earth or any other planet. But imagination doesn't always care about facts. The first interstellar object, Oumuamua, sparked a wave of books, articles, and debates about alien technology. The second, Borisov, drew less attention because it acted like a normal comet. This third visitor falls somewhere in between, familiar enough to be studied, strange enough to inspire dreams. Some look at its odd behavior, the early coma, the irregular pulses, the strange chemistry, and wonder if it might be alive. Could a comet itself be a kind of organism, feeding on sunlight and venting gases as it drifts between stars? Others imagine it as a probe, deliberately designed to swing through planetary systems, gather information, and move on. Science fiction has long played with these possibilities. In Soviet writer Ivan Efremov's Andromeda Nebula and Hour of the Bull, Earth encounters a galactic civilization. Western classics like Arthur C. Clarke's Rendezvous with Rama imagined massive alien ships disguised as comets. 3I-ATLAS echoes those ideas, a silent messenger from the void, slipping past our defenses. For now, though, it's just speculation. The real stakes are different. Every interstellar object that passes through is a once-in-a-lifetime chance to study materials from beyond the solar system. Their chemistry and behavior tell us what conditions are like in other star systems. Each one is a natural probe, carrying clues about the galaxy we live in. And that's why 3I-ATLAS matters. Not because it's an alien craft, but because it reminds us how little we know about what's out there and how much we still have to learn. Still, the what-ifs persist. And maybe that's part of the story too. The mix of fear and wonder when humanity looks up and sees something coming from the dark. A messenger from beyond. So where does that leave us with Comet 3I-ATLAS? For the scientists tracking it, the mission is clear. This comet is a messenger from beyond our solar system, only the third of its kind ever seen. And once it's gone forever. That's why telescopes and spacecraft from Earth to Mars are already locked on, gathering every bit of data they can. The timeline is tight. In October 2025, the comet will sweep to its closest point to the Sun, just inside the orbit of Mars. In November, it brushes near Mars itself, only 18 million miles away. By December, it makes its closest pass to Earth, still a distant 167 million miles, before vanishing into the black. After that, it will fade from view, never to return. Between now and then, every observation counts. Hubble and Webb will measure its coma and tail in different wavelengths. Mars orbiters will give us unique angles we've never had before. Ground-based telescopes will capture light curves, tracking its irregular flickers. Each piece of data adds to the picture of what this interstellar visitor is made of, and where it might have come from. And while the scientists focus on measurements, the public wrestles with imagination. The transcript of anomalies, early coma, strange chemistry, irregular pulses, keeps alive the idea that maybe, just maybe, 3I-ATLAS isn't entirely natural. A probe, a vessel, even a living object. Most astronomers reject those claims, pointing to natural explanations. Fractured ice, random venting, unstable spin. But the speculation is part of the story too. It's what happens when something arrives from deep space, when humanity confronts the unknown. There's reassurance in the facts. 3I-ATLAS poses no danger to Earth. It's a scientific opportunity, not a threat. But there's also awe in the unknown. This tiny nucleus of rock and ice has traveled for millions, maybe billions of years, only to pass briefly through our skies. When future generations look back, 3I-ATLAS may be remembered as just a rare comet from another star. Or maybe it will be remembered as the moment humanity realized interstellar visitors are more common than we thought, that our solar system is not as isolated as it seems. Either way, the lesson is the same. The universe is bigger, stranger, and far more alive with mystery than we can imagine. And as 3I-ATLAS races past, we're reminded that at any moment, something else could emerge from the darkness, carrying new questions with it. The mystery continues. Make sure to like, share, and subscribe, so you're always the first to see our next video. Thanks for watching, and I'll see you again in the next one.